We talked about solving systems of equations by graphing the lines and looking for that common point of intersection. Now we're going to talk about using the elimination method. So we call it the elimination method because that's what we're trying to do. We're trying to eliminate the x or y variable value, whatever. Okay, so for our steps, we want to make sure our variables are lined up. And then the second step is to make sure you have inverse coefficients. For at least one. Variable. And remember, for inverse, we're talking about opposites. And then we will add the two equations together, and that will eliminate the variable. Okay, so if we look at the first example, we want to make sure our variables are lined up. And here I see the x's are together, the y's are together. I also want to make sure the equals are in the same spot and our constant terms are in the same spot, and they are. So step one is good. Then I want to make sure I have inverse coefficients. So if I look at the first ones, I have a positive 2x and a negative 2x. This is what I'm looking for, because if I add negative 2 to positive 2, these two numbers are going to equal 0, and we will eliminate that x value. So I'm going to need my calculator so that I can figure this out or find the solution. Okay, so if I do negative 2 plus 2, we will see we get that 0, and this eliminates. Okay, and remember, I'm adding these whole equations together. So now I'm going to add negative 8 plus negative 6. And I get negative 14. So remember, these are like terms. I can add the y's together. Here's equals, and then I have 10 plus 18, and I get 28. Now I can just solve this for y by dividing. This is multiplication, so I'm going to divide both sides by negative 14. So what is 28 divided by negative 14? It's negative 2. Okay, if we remember from our notes from yesterday, we were looking for that point of intersection. So our answer is an ordered pair. It's an x and a y. So when I look at this, I see that I got y equals negative 2. So I have my y value. So I need now to get my x value. And the way I can do that is I'm going to substitute this y value into one of our original equations to get that. It does not matter which one you pick. I'm going to pick the first one. I'll just pick the first one. So if I've got negative 2x minus 8, and I'm going to leave a space for this y because I'm going to substitute that negative 2 in. So I'm substituting the negative 2. So now I will evaluate this. I have the negative 2x. There's nothing to do there. Here I have negative 8 times negative 2, which gives me negative 8 times negative 2 is a positive 16. And then to finish solving, I will subtract the 16 to the other side. Remember, there's that invisible line. So now I have the negative 2x. 10 plus negative 16 is negative 6. And then I'll divide by negative 2. So x equals negative 6 divided by negative 2 is 3. So my x value is 3, and this is the solution to that system of equations. If I graph these two lines on the coordinate plane, they will cross at the point 3, negative 2. Let's try another example. So again, we want to make sure our variables are lined up. X and x, y and y equals constants. Now we want to make sure we have some inverse coefficients. So here I have a negative 5 and a negative 1. That's not going to give me 0. Here I have a negative 4 and a positive 4. Negative 4 plus positive 4 is 0. So this is what I wanted. So I'm good to go. And I can start adding. So again, I have negative 5 plus negative 1 is negative 6x. Negative 4y plus 4y is going to be 0. So I eliminated the y. Negative 15 plus negative 3 is negative 18. I do the opposite of multiplication, which is to divide. So I get x equals negative 18 divided by negative 6 is a positive 3. So for my solution, I have found the x value of 3. Now I can take that x value and I can plug it in for this x or this x and get my y value. So this time I'll just pick the second equation just to show you it doesn't matter. And I'm leaving out the x because I'm going to put that 3 in there. So it's negative x plus 4y equals negative 3. And instead of that x, I'm putting 3. So negative 3 is just negative 3 plus 4y equals negative 3. I'm going to need to add the 3 over to this other side. So that gives me 4y equals 0. And then I have to divide both sides by 4. And 0 divided by 4 is 0. So my y value is 0. And here is my solution. For example number 3, I'm looking to see, I have my x's lined up, my y's, my equals, my constants. And then I need to look for inverses or opposites. So I have 2 and 1. Those are not opposites. I have positive 5 and positive 5. These are not opposites. So what I notice is that I have 5 plus 5 gives me 10. This is not going to eliminate my y. But if one of these was a negative, then it would cross out. They would cross out or cancel. So I can pick either this equation or this equation to multiply by a negative 1, which will change the sign. I'm going to pick the second equation just because, no special reason, and we'll see what happens. So this is my top equation because I am not changing that one at all. But here I have negative 1 times x, so that's a negative 1x. Negative 1 times the 5y, so that's minus 5y. And I have negative 1 times negative 10, so I have to multiply it by everything. Negative 1 times negative 10, or multiplied, is a positive 10. Now, if you see, if I add a positive 5 and a negative 5, I get 0, and they will cancel out. So, 2x plus negative 1 is a positive 1x. 5y minus 5y is 0, equals 0 plus 10 is 10. So I get x equals 10. So I know my x value. Now I need to find my y value. And again, I can pick either my first equation or my second equation. I'm going to pick my second equation. So my x I'm leaving out because I'm substituting. Plus 5y equals negative 10. And I am substituting the 10. So here I have 10 plus 5y equals negative 10. I will subtract the 10 to the other side of the equal sign and get 5y equals negative 20. And then I will do the opposite of multiply and divide and get y equals negative 4. So negative 4 is my y value, and the solution is 10, negative 4. For my last example, I have my x's, my y's, everything is lined up. I do notice that I have 2 4x's, but they're both negative. I need one to be positive. So I can multiply through. Again, doesn't matter if it's the first one or the second one. I'm going to multiply everything by a negative 1, and that's going to change my signs. So negative 1 times negative 4x is positive 4x. Negative 1 times a positive y is a negative y. And negative 1 times 9 is a negative 9. And I'll just recopy my second equation. So now when I look at this, I will see if I add the 4x and the negative 4x, 4 plus negative 4 is 0, and I will eliminate the x. So this is good. So negative 1 plus 9y is 8y equals negative 9 plus 17 is 8. I will do the opposite of multiply, and I will divide. So 8 divided by 8 is 1. So now I have my y value of 1, and I can substitute that here or here to get my x value. I'm going to pick my first equation. It doesn't matter again. So negative 4x plus y equals 9. And I'm substituting the 1 here. So I have negative 4x plus 1 equals 9. I will subtract 1 to the other side. 9 minus 1 is 8. And I will divide by negative 4 to get x equals 8 divided by negative 4 is negative 2. So my x value is negative 2.